even though we have many methods here, but we try to transform that become a single objective. Multiple, we transform to a single objective to solve that. So I will tell you later. But actually, here for MODM we have many professors, but I select this one because you familiar with this professor, George Denzis. You can find out and you can read about him. He have like big contribution in MODM. Okay, so as I mentioned, MODM is multi-objective. We have more than one objective. So why we solve that problem? Because in the real life, we not only solve with one objective. So I want minimize the cost, but I want maximize the qualities. I want minimize the cost, but I also want to maximize the service satisfaction. So like this. So we usually we want many ambitious. So that's why we need to solve that problem. But if we want a lot, we expect a lot. How can we reach that goal? So how can we reach that goal? So I will tell you how. MODM, that is the special combination. So why we can call that the special combination? Special combination among like each single objective here. But single objective must be conflict. If not conflict, so we cannot call that the multi-objective. So for example, I want to maximize the qualities and minimize cost. So here is Z1, Z2 is Z1. Everyone, you know that if we want to minimize, you just pay minimize money, but we can get the maximize quality. Can we do that? Everyone? Can we do that? That can happen? Hello? You think we can do that? Cannot, everyone. Who can give me your idea, your opinion? Cannot. Hello, everyone.
Can you repeat the questions, please?
My question is, you want to minimize the cost. Just pay a little money and you get like maximize the qualities. So can we achieve both? So maximize qualities, and minimize the cost. That is conflict. Conflict. So high qualities. High qualities. You must to pay more to get high quality, right? So for example, if you want to buy a cell phone, it's high quality, you must pay more. But you just pay minimum one and get maximum. It means like you can pay um, right now is what is the latest version for iPhone? I don't know, but it's you want to get that qualities, but you just pay a little money. Can we buy it?
No.
No. No, right? Cannot. Cannot do it. But the human, they want both. They want more than one. They expect they can maximize quality, and they expect that minimize cost. So how can we can do it? But first of all, I want to clarify what is the conflicting. Two objectives. So how can we know that it is conflicting? So I just give you example. So I maximize the qualities of the product, but I want to pay a little money. That is the conflict. So I want you give me example what the conflicting of the objective. Because many students when they do thesis, so they are confused. They don't know whether Z1 and Z2 conflict or not. So they just put together and they solve that. But they don't have any idea about that, even though they take the MCDC course. So right now, I want you to tell me, and we analyze on your example to see whether the objective here conflict or not. So please give me the example. Just give example what you're thinking. I don't care about that is correct or not. I just want to take that example to analyze. Hello. Yes, please. Go for it.
That for example, we are both working and studying at the same time, so we want to have good grades, but we also need to work for money, and so we don't have so much time for studying. So if we want to get a good grade, we have to sacrifice some of our working hours to study. So these two are conflicting.
Yeah, but what you maximize, what you minimize.
Maximize the good grade and minimize.
Grade
Yes,
and minimize
minimize the working hours.
working time,
Yes.
study time, right? Study time. Yeah, I think that is also the conflicting. But the problem here, the problem when you think about that, like clarify. So when I write like maximize the cost or minimize the quality, so I must to clarify exactly what cost. So exactly what it costs, what the qualities. So you maximize the grade here. When we talk about this, so we can see conflict. But when we formulate, we must to clarify. So what cost? So you
I think I should I should change to the studying hours so that we could both work and study at the same time
no, and
and
here
minimize.
here is correct. Here is correct. But when we like do in the model, you formulate. So we must to clarify that, right? Score, but you want to maximize score, total score, or you want to maximize one cut. You know what I mean? So when I say minimize cost, so what is the cost I want to minimize? So for example, I want to minimize the cost, that is the traveling cost or inventory cost. So we must to give the specifics. Here is, I think is correct. Maximize minimum number of worker. So Quang Minh give example with number of worker and the completion time. So can you tell me why that is conflict?
Because we cannot minimize the number of worker and the completion time at the same time.
Yeah, but right now we I want
You
you.
want to choose the max and the mean, right?
Yeah.
Okay. So we can use an example from Joe. That is, we will maximize the accuracy.
No. Here you okay. You can minimize number of worker, right? You minimize number of worker. Number of worker, and you
Yes.
maximize what?
Like
Because the number of worker, you minimize number of worker is mean the worker is few worker.
fewer. Yes.
Yeah, and completion time. So if you have fewer, so completion time.
Will be longer. So I mean, we cannot minimize both parameters at the same time.
So you can minimize or maximize.
Yeah. If we want to minimize the completion time,
Yeah. Completion time, right? Okay.
yes.
So you can minimize. That's why I will ask you to give me example. We will analyze on that one.
Yes.
Okay. And y'all give like maximize accuracies and minimize time to complete the projects. Yeah. Yeah, maximize accuracies. But the problem here, um, y'all, the problem when you maximize the accuracies, you must to define what are the accuracies here. You must to define that. So, like when I talk about I want to maximize the quality. So exactly, we don't know we don't know exactly what are the qualities here. Quality of the cell phone, maybe we maximize like um, about what duration or battery quality. What I mentioned about quality, I must to define that. So for accuracies, you also define that because the reader they don't know, and you also because we should modeling that, so we should define it clearly. Okay. Mm, yeah, actually, that it also can apply in the company in industry. Industry when we like finish the project, so we want to minimize, maximize the accuracy. Is mean we minimize the errors, right? So when you give here maximize accuracy, so you can change that minimize the error. So you can define error is easier than if you use maximize accuracies. Okay, cháu. Okay. So do you have any other example we can analyze on that? Everyone? So if you don't have, so I will move on to. But what I'm trying to say here, this is conflict, but not just only have to maximize and minimize. Can minimize and minimize, can maximize and maximize. But so as long as it's completely conflict, is okay. Yeah, one more question I want to ask you. So how can we know that there's conflict, everyone? Say one sentence for me. How can we know that it conflict? How can we recognize that two objectives that they conflict? So you just give me many examples like this, right? It's correct, but how can we know that?
So we can ask the questions like, if this is higher, then will it be higher? Like, if the completion time is higher, then the number of worker is higher or not. Then if that is direct proportional, then that is not conflict, right? Yeah.
Yeah. So it means they have relationship. First of all, they must have relationship, right?
Yes. And we check if that is inverse proportional or not.
Must be have relationship. That is first of all. So conflict is mean one increase, another decrease. Is
Yes.
it?
That's right.
Yeah. So everyone, if you want to check that a conflict, first of all, we must to investigate if that is have relationship. If they have relationship, it mean they will one increase. We have two ways, right? If they have relationship, so one they have like positive correlate, or we have negative correlate. So here conflict is negative correlate. One increase, another decrease. Right? So negative is not positive though. Positive is mean this increase, another increase, right? Yeah, remember everyone. So when you do the thesis also, you must ask yourself that question. So, but everyone, when you write the name here, for example, you write minimize the completion time, minimize the number of workers. You cannot see the relationship. So sometimes we cannot see if we just give the name like this. So what should we do? So you can write the formulation. You write down the formulation of this one. And you can see, you can investigate if you increase this. So what happened in the rest of objective. Okay. So sometimes you give the name here, but they don't have relationship. So that is much depend on the formulation you put in here. So you have X, you have Y, you have something in formulation. So you consider with compare with Z1 and Z2. So you can see inside of the objective. So you will know that is conflict or not. Okay. So any question about what the conflicting? Okay, that is very important. So I spend a lot of time here. Very important. So and I ask you the question like, we cannot reach pole. You cannot reach pole objective simultaneously, right? At the same time, we cannot. So right now, what is solution? What is solution for this case? So solution for this case is satisficing. Satisficing that it combined from the satisfying and sacrificing. So if you satisfy this one, it means you read that one. So you must sacrifice the second one. So but the level, like the degree of the satisfying and degree of the sacrificing, that they depend on decision maker. So you can select like satisfy more. So satisfy more in the first one, so you will sacrifice more in the second one. Okay, that is, we have the satisficing terminology in the MODM. So go with the modeling here. So model of the MODM is the same with the single objective. We have maximize, but the main difference here have more than one objective, and they are conflicting. So and everything the same with the single objective. Okay. So here example. So we have maximize Z1, we have maximize Z2, and here we have subjective. So that is the example for MODM. But I go back with this example later. So in here I give you one example. Maximize Z1, maximize Z2, and here. So For example 1, I find no optimal solution. But for example 2, I find the optimal solution is 0, 3, 0 and 3. So my question is, so here's why we have two objectives. I find the optimal solution. But you know that, as I mentioned earlier, just only single objective we can find the optimal solution. But here I have two objectives, but I can find the optimal solution. So what happened in here?
I think the objective is not conflict.
Yeah. The objective here is not conflict, right? So you can see here. So I use this example to illustrate what I'm talking about. If we just like write the name here, maybe we cannot recognize exactly that it conflict or not. So we must to write down the formula, right? Z1 equal x2, Z2 equal to x2 minus x1. So you can see here, if we increase x2, so increase x2, it means Z1 increase, right? Increase x2 in the second one, so Z2 increase. So obviously here, not conflict at all. So that's why I ask you, if you cannot recognize in here conflict or not, you must write down in the formula. Okay? Clear, everyone? So in here, you can see if x2 increase, x1, x2 here. For example, x1 increase, right? So x1 increase, z1 increase, but x1 increase, so let's z2 here decrease. So we have no optimal solution. That is conflict, objective conflict. Is that clear, everyone? Any question for me? Okay, so here we have the optimal solution. So as I mentioned, in here we don't have. We have efficient solution. We have the best efficient solution, ideal solution. So right now, we go to one by one. So what is the efficient solution? So we don't have the optimal solution. We have. So if I write here, maybe you confused by feasible solution. Everyone help me to correct that in feasible solution. So optimal solution here is just explain for so sorry. So optimal solution here just explain for single objective. So I define here, just remind that for you. a single objective. Single objective optimal solution for single objective is mean when we find here we have many solutions, but if that is the optimal, so fx here, fx star here will be greater than or equal other for any point belong to this region. Okay, because that is the best. If that is the best, so when we substitute in z here, z will be that is the best one. Okay. So in here we have, so right now we move on to efficient solution. Efficient solution, we use that for conflicting objective. But before we know about the efficient solution, let me tell you the dominant first. So dominant. X is dominant, x1 dominant x2. If solution x1 is no worse than x2 for all objectives. And solution of x1 strictly better than x2 is at least one objective. So I will give you an example like this. So if you have like A1, you have A2. So for example, you have, compare that, you have 3 criteria like qualities, like performance, just example, like cost, quality, performance, what else? For example, cost is like this. So we compare pay on that. But this one, greater than, equal, greater than, equal, greater than, equal, greater than, all that is greater than. Quality, performance, and cost here. Greater than is mean, is the cost here is better than that cost. But in this, we compare here, you see, solution of x1 no worse than x2 for all objectives. So we don't have any criteria is worse than that, right? But only one strictly better than. At least, so solution of x1 strictly better than at least one. So for example, we have here at least one. If we satisfy here, so A1 dominate A2. If that happens, so A1 will dominate A2. It means better than, right? So, and any question for me about the dominance? If we consider 1, 2, 3, so that is no worse than that, but have one strictly better than. So A1 dominate A2. It's okay. So right now we clear on the dominance. We move on to efficient solution. So what is the efficient solution? Efficient solution, they have different names, territories. We have different names, like Pareto solution. Pareto, that is the name of the mathematician. So we take that name for the solution. So we call that a Pareto solution. Frontier solution. or we can call that the parietal front, a non-dominant solution. We have many different names with the same meaning. So, but what is sorry, so what is the efficient solution? So I will give you example. Efficient solution. So you look at this figure. So this figure also can show, but I want you clear on that. So I'm just add in the view one. Look at the slide, everyone. So I want buy a car. So when I buy a car, so I consider two objectives: cost and the comfort. Cost and comfort. So it means high cost is more comfort, right? High cost is more comfort. But right now, we try to find the solution. So we have like here, that is the feasible region. Feasible region. Feasible region. That is the solution in here. All the solution is here. So right now, we choose which one is the best one, right? So it's like here, which one is the best one. But in here, we call that which one is the efficient one. So efficient solution. So optimal solution, you may have more than one. So efficient solution is also have more than one. May have more than one. Okay, so right now, if you look at this, so I call A, B, C, D, E, F in this curve, that is the parietal efficient or parietal optimal front here. So that is the efficient solution. So why and how I can define that is the efficient solution? So you see, they get small money, small comfort. B, if you pay more, so you have more comfort. So A and B is non-dominant, right? You pay small, you get small. You pay more, you get more. C, more cost, you get more comfort. D, more cost is more comfort. E, more cost is more comfort. But if you look at X, and Y, so X, you have fuel is small cost, but a small comfort. Y, you have more, pay more, you get more, pay, you get more. That's right. So X and Y here, that is the non-dominate. X and Y non-dominate, right? But if you compare A and X, B. If you compare B and X, or C and X, so you see B, we just pay small. You pay small, but you get more than X, right? X pay more but get small. Pay more but get small comfort. So B is dominant X. C also dominant X. D also dominant X. Okay. So in sum, What is the efficient solution? Efficient solution is mean we just in this area, so the point satisfy. Does not exist any x belong x, such as fjx greater than fjx star for all j. Fjx greater than for at least one value. So if you look at this here, so if you compare with cost, so is cost of b better than x, right? If you compare comfort of b is greater than, and so no one better than b here. We cannot find any point here better than b. No point better than a, no point better than c, d, and f here. So the line here, we call that the efficient solution. Each point in the segment here, we call that the efficient solution. Okay, everyone, any question? Clear on this one? So if you have no questions, so I move on to the best efficient solution. So that is the efficient solution. So we have like many solutions here. So the question is, which one is the best one? So which one is the best one is depend on decision maker. For example, if you have just like 10,000, around 10,000, your project just around 10,000. So the best for you that is A, right? If you have more than like 15,000, just only around 15,000, so the best for you just B. So if you want to choose which one is the best, you must to add some criteria here, right? If you don't have any criteria, so they are non-dominant. So no one better than other, right here. So if you have some criteria to add here, you will choose which one is the best one. Okay. No questions, so I move on to ideal solution. So what is the ideal solution? So in top six, right? Top six, we mentioned about the ideal solution. Top six. Ideal solution. So ideal solution is mean like this, right? That is the negative ideal. So ideal here we collect like everything, every characteristic, the best. So we put on here. That is the ideal. Here, the worst, right? Worst. We put the worst in here. So that is the negative ideal. So the same, the ideal solution here also collects the best one. So for example, if you have like maximize profits, you minimize, you maximize comfort here, minimize cost, right? So maximize comfort, minimize cost. So, and you have subject to here. So you take maximize here, you combine with the subject to, you solve the single objective problem, right? You take max, combine with the object and subject to here, you can find a solution. You can find a maximize here, maximize. So you have Z1 star here, right? So the same, the second one, you check minimize with the subject to here. You have Z2. So that is the ideal solution. So corresponding here we can find X, right? X star 2 star. We find the ideal solution here. So as I mentioned earlier, we cannot like achieve both objectives at the same time. We cannot. So right now we like isolate. We just take one, we solve that. Each one you get that. So each means that the ideal we cannot reach that one, right? Everyone we cannot. No, cannot. So that is ideal. We expect we can get, but we cannot. The ideal solution, everyone clear? So I will give you example. So I have 1, 2, 3 objectives. I have subject to here. So you can see I take the objective, this one, combine with subject to here. I solve the problem. So I get a solution here. X1 equal 2, X2 equal 3. Right? I substitute in Z1 here. Z1. So I get 7. So the same for the second one. So I get 12. The third one, I get 1 here. 7, 12, and 1. 1 here, how can I get 1? So I take 2 and 3. I substitute. No, I take 5. I take 5, 2. I take 5, 2. I substitute in Z1. 5, 2. So I get 1 here, right? I get 0, 1, 0, 1. I substitute in Z1. Here is 0, 1. So I get Z1 equal 3. Here that is 3. So the same. I have the payoff matrix. The payoff matrix here can show you. So for X1, you can see X1, for Z1, 7 is the best, right? For Z2, it's 12 is the best. Z3 is 1 is the best. That is the ideal solution. Okay. Any question for me? Teacher, how you can repeat again this slide? What slide? This slide. Yeah, so right now we have the maximi. We want to find the ideal. It means we find the best one of the Z1, the best one of Z2, the better one of Z3. So how can we find that? So it means we just celebrate Z1 you solve with this problem. So you get the solution here. Okay, and the result the same. You do with C2, you get the solution here. You get C3, you get the solution here. Okay, if you separate each on objective, so you will get the best for each of them. But if you put in here, you put three together to solve, so we cannot get Z1 maximi, cannot get Z2 maximi, can get Z3 maximi, because we satisfy, we must sacrifice, right? So I separate that to find the ideal. Why we need to find the ideal here? We find the ideal is mean. So here, if we combine three objectives, we combine three objectives here. So we cannot find here if we combine somewhere here. So we find the ideal is mean we try to minimize here, minimize distance. Close with the ideal is the better. Okay, Uyên, hello Uyên. If you're not clear on this, so continue to make the question. Okay, clear. Các bạn ở chỗ này cô nói cho các bạn rõ chỗ này ha. Mình muốn tìm cái ideal solution đó, thì mình phải tách nó ra. Tại vì chỉ bản thân giải một mình nó, một cái objective thì mình mới tìm được optimal solution. Optimal thì mới là the best, đúng không? Thì mình phải tách nó ra. Tách nó ra từng cái mình giải. Thì mình tách ra 3 cái, mình giải ra 3 cái điểm đó. Mình gom 3 cái solution đó lại với nhau. Thì 3 cái solution đó là tốt nhất rồi. Tốt nhất cho trường hợp này, với cái constraint này, với những cái model này, thì 7, 12, 1 là tốt nhất. Nhưng mà nếu mà mình để 3 cái vào với nhau này á, 3 cái vào với nhau mình giải, thì mình không thể nào đạt được 7, 12 và 1 cả. Tại vì mình bỏ vào với nhau, tại nó conflict mà. Một cái mà em đạt cái này maximize nè, em nhìn nè, ví dụ như cái này mà em đạt maximize là 7 đúng không? Thì cái số 2 của nó chỉ là 7 thôi, và cái số 3 của nó là chỉ là âm 1 thôi. Nó không thể nào đạt được hết. Cái số 1 mà đạt 7 á, thì cái số 2 không thể đạt 12 được, và cái số 3 cũng không thể đạt 1 được. Rõ ràng em thấy không? cái số 7, cái 1 mà đạt maximize là 7 nè, thì cái số 2 chỉ đạt 7 và trừ 1 thôi. Nếu mà em lựa chọn là satisfy cái số 2, satisfy thì 1 nó chỉ đạt 1 thôi, và cái 3 nó và tương tự. Nếu mà em chọn thỏa mãn cái 1, mình đạt cái 1, đạt cái 3 cao nhất là 1, thì những cái còn lại nó chỉ là 1 và 3 thôi, chứ nó không thể nào đạt 7 và nó cũng không thể nào đạt 12 được. Có em vào đây sẽ thấy cái nào là cái satisfy và sacrifice. Cái mà ideal là cái không muốn đây nè. Cái ideal là mình tưởng tượng thôi chứ nó không xảy ra được. Vì tại sao mình cần phải tìm ra cái điểm này? Tại vì mình muốn tìm ra điểm này là mình muốn tìm một cái điểm nào mà gần với cái điểm ideal này nhất thì nó là the best, đúng không? Tại vì cái ideal này nó không có thật thì mình chỉ cần tìm cái nào gần với nó nhất, thì sau đó mình sẽ học. Ok, các bạn rõ phần này chưa các bạn ơi? Hello, just say something. Understand? Yes or no?
Yes.
Okay, so I just waiting for you to say yes. Right now we take the break, 15 minutes break, and after that we continue. Okay? The result of the projects when we apply to the real problems. Là Châu hỏi gì ta? Hỏi project in lớp hả Châu? Đây là Châu đang hỏi về cái bài học. Không phải, nãy cô nhìn nhầm. Cô nhìn không, không phải. Sorry. Okay, just take the break. Hello. Hello. Bạn quay lại chưa các bạn ơi? Các bạn quay lại chưa các bạn ơi? Hello. So please let me know you are
Dạ
here.
ơi.
Hello. Các bạn ơi, các bạn trả lời giùm cô các bạn. Yes. Uyên Phương, are you here? Okay. So we just know about model, right? So right now we show that how to solve the MODA problem. So right now how we show. Okay, we use the global. I introduce you about the global criterion, right? Global criterion. Global criterion methods. So let me talk about the idea behind the global criterion. So idea of this one, we have like maximize, minimize, ZI, ZIs. So I from 1 to K, and we have subtract 2. So when I write that is mean we have multi-objective, right? Multi-objective, and we have subtract 2. J, that is J, I better than BI. Okay, so I is from 1 to n. If we have problem like this, so right now we use the global criterion to solve the problem. The idea we try to find the ideal. Try to find the ideal solution. Okay, and after that we minimize the distance here. So here that is like z1. For example, if we have two z1, you combine with the ideal one. Z1 you compare with the ideal is Z1 star. We minimize the distance here. Mean. So if you have Z2, so the ideal of Z2 here, Z2 star. So maybe Z2 here. So we minimize distance. So we take sum. If you have Z3, so you compare with ideal of Z3. So you can see here, we minimize sum of. So we take sum of this. If you have Z3, so you plus with Z3, right? So in here you can see that they take the Z star minus Z divide for Z star. So 0 here. So Z star is mean from here to here. That is Z1 star, right? Here that is Z2 star. Check that, divide for Z2 star. That is Z2 star. From here to here, that is Z2. From here to here, that is Z2 star. Z1. So it means here we transform that. We have model mean Z equal to Z1 star X ZI. So here is J minus Z, J. Sum is from I to K. So what we can see in here, everyone, so that is the multi problem. We transform that become single. Here that is the multiple objective. We transform here become single objective, right? Is it single objective? So for single objective, it's easily we can solve. Okay, that is the ideal. Any question for me? So you may ask me what is the P here. P will be equal 1, P equal 2, and P equal infinities. So that we already studied in top 6, right? 1, so we just put 1 here, it be 2. 2, that is the Euclidean. Infinity, that is the maximin. A minimax. Okay, everyone. That is okay for you, right? So right now I give you example. Example, that is the production scheduling of the Hattie toy company. So the company they produce two toys. One is door A, high qualities. B, that is lower qualities. So they expect the profits for door A 0.4, 0.3 for door B. And door A is require twice as much as door B. And the so they can produce 500 door per day, include A and B. Uh, if if all door were on B, the company could make 500 per day. So the supply of the material sufficient for, so it means they just have 400 door per day. They just can supply the material to make 400 door per day, include A and B. So they have two objectives, that is to maximize profits and maximize the production of door A. So right now, first of all, you must do formulate, right? Formulate. Everyone, I give you like 5 minutes to summarize and formulate that problem. 5 minutes. Hello. So what about your formulation? Everyone, in here we have two objectives, right? Objective, formulate. Maximize what? Maximize profits. Profits. Maximize profits. Everyone, you remember how to formulate? Profits is the one, right? Which one related with profits? 0.4 and 0.3. So how many decision variable, everyone? A and B is XA and XB, right? That is 0.4 and here that is 0.3, right? And maximize the production. Maximize production A. So Z2 equal to XA is subjective. Everyone, what about your subjective? Please let me know. You can type that in the chat box, please. Hello. XA equal to XB. XA equal to XB. So why X? So what? Uh, so look at this one. The supply of the material sufficient for only 400 door per day combined both A and B combined. So why XA equal to XB? Jan, can you give me the reason?
It is because the time constraint.
Uh-huh.
Each door A requires twice as much time as a door B.
Door A time. So here XB B that is the number of product A. Number of product B. B. So here that is the number of product A. So if you write like this, so number of product A will be equal try of number of product B. So it's not time, right? Jan, can you recognize that one? Can you realize that? Yeah. So that is the number. So the information they give you that is the time. So we try to transform time related with the number. So please everyone, you just comment on here so I will analyze that. So you can learn more about like from your idea, from your suggestion here. You think what you think, you just type in here, please. Thank you very much, Jane. Everyone, please. XA, yes, XA plus XB greater than 400. Correct, correct. Because they says what? The supply of the material sufficient only for $400 per day, both A and B combined. And what else? Correct. Let me ask students. Đinh Phú Vinh. Hello, Vinh.
Yes.
Your constraint.
XB smaller or equal to 500.
XB small 500. So, why you write the constraint here? What you pay up?
Because I see in the problem they say that if all those were of type B, the company could make a 500 per day, I think.
What you can see here, you can see here XA plus with XB better than XB will be lesser than 500. So okay, it's fine if you can put that, but I have redundant. They give the information that because they have like the first clause that each door A requires twice as much time as door B, and if all doors were type B, the company could make 500 per day. So try to combine two clauses so you can find the constraint. Why I choose that? I choose this one. Two XA plus B. So why 2XA plus B lesser than equal 500? Phương. Hello, Phương.
The equation means that if we make all dough B, then we can make a maximum of 500 doughs. And if you make all doughs A, then the maximum is 250 doughs. Because dough A requires twice as much time as dough B.
Yeah, so you can analyze that. For example, so here we mentioned about they said like time, right? They give you time, but here that is the unique. They give information like time, right? But here that is unique. So you have any connection time with unique? XA time. Yeah. Yes. Okay, everyone. So, so we just think simple like that. If they do only B, so it should be 500, right? But they also want to produce 8. They also want to produce 8, right? But 8, they spend twice times. So we have like this. Okay? You can recognize that this string is correct, Jane. Thank you. Thank you for. Okay, we have the formula like this. So right now we short that. We want to short that. So I give you the suggestion so you can practice at home. Practice at home. Right now we take maximize profits here. You combine with this one. You sort this one and this one combine. You can find, for example, Z1 here, K1. You K1, you combine Z1, maximize model like this. Maximize Z1 0.4xa plus 0xb and subject to like this. 1, 2. So 1, 2. Yourself. And K2 use that is 1 star, that is 2 star. So that is 1 star, right? You maximize 1 star and subject to 1, 2. And you get the solution. Okay. Solve that and get the solution. So from this one, you can find the ideal. Find the ideal solution. Right. And after that, we transform. After that, we minimize distance, right? Minimize fx here. Because you have ideal, you have z1, right? You have z2. So you take mean here. Will be z1 minus f1, the f1 here, minus f1. 0. Okay, you divide for z1 star, u plus what? z2 minus 4x1, right? You divide for z2. Okay, in here that is p. We saw with p equal 1, p equal 2, and p equal infinities. So I want you to practice at home, and next class we will solve that problem. Okay? So in the slide, I already solved that, but I want you to practice by yourself and to see that if you have any question. So we will discuss in next class. Okay? Any question for me? Hello. So that is, you must to finish practice. You have no questions, so we can stop here and see you next class. Any question, please? I'm waiting for your question. Okay, if you don't have, so see you next class. Bye bye.
Video thanh lý tiếp theo. Như vậy là lần thanh lý lần trước đã kết thúc rồi. Mình cũng đã đóng hàng và gửi đến những bạn may mắn. Có những bạn thì đã nhận được máy rồi và có những bạn thì đang còn trong quá trình chờ vận chuyển nha. Hôm nay thì mình sẽ tiếp tục thanh lý tiếp và cái lần thanh lý này thì cả được thấy cũng rất là ngon bởi vì những con máy
Các bạn nào mà bye bye.